Hello wonderful person, this is Anton, and in this video we're going to be discussing Titan, the largest moon of Saturn that also represents one of the most mysterious and potentially most exciting worlds outside of planet Earth that we know for a fact contains some kind of a liquid cycle on the surface. Second of all, it contains that mysterious dense atmosphere and a lot of different hazes, including hazes made out of methane, which at least on Earth have been associated with potential bacterial life. And third of all, it of course contains what seems to be active bodies of liquid, tiny seas and very large lakes that we know change with time. And so thanks to missions like the Cassini mission and the Huygens probe that actually landed here and took a few pictures, which you can learn about and even look at in one of the videos in the description, and more recently thanks to the observations from the James Webb Space Telescope, we're now slowly starting to solve some of its mysteries, while at the same time making some really exciting and unexpected discoveries that we're going to be discussing today. Because some of these new discoveries are truly astounding, making Titan one of the most unique moons in the entire solar system, and definitely one of the most exciting objects out there, just because of all of these individual components. And so by studying Titan, it gives us a unique window into various planetary dynamics, and crucially helps us understand how various life's ingredients can possibly form in a lot of alien environments. And so today we're going to discuss a few studies from just the last few months, all of which, as always, you can find in the description below. But in essence, all of these studies discover something new and unusual about Titan, and something that has never been considered before, or something that nobody ever realized. And I guess let's start with some of the discoveries in regards to its atmosphere and even its weather. Because in order for this world to look so similar to planet Earth, both its weather and its atmosphere have to be incredibly active. And this is what this study from May of 2025 was all about. Because here this involved understanding how methane moves around the Titan's northern hemisphere, where most of its large seas and most of its lakes seem to be located. And so by using the Keck Observatory and observing Titan from the surface of our own planet, here researchers found the first evidence of actual cloud convection in the northern hemisphere of Titan. And convection in this case is essentially the circulation of heat and moisture, like for example air rising on a hot day, and then forming clouds that eventually form rain. And so here researchers watched methane clouds near the North Pole evolving and changing over multiple days. They essentially saw the clouds moving upwards in the altitude, extremely similar to what we usually observe in various convective cells on our own planet. And this was a vital discovery because it helps us understand Titanian climate cycle, and also how these methane clouds can generate rain and thus replenish liquid methane that has to be evaporating from within these lakes. And so for the first time ever, we physically have evidence of a liquid cycle on another world. But not water, methane. But there is still, I guess, a bit of a mystery. Where exactly does all of this methane come from in the first place? And that's because methane in general is somewhat unstable, especially in Titan's upper atmosphere. For example, sunlight or a lot of cosmic rays can easily break it apart very quickly, which usually leads to other molecules, such as, for example, dicarbons, so things like C2H6. And so technically all this methane should be depleted pretty quickly, naturally suggesting that over time, Titan should basically lose all of its atmosphere, becoming some kind of an airless world. Yet what we see is obviously completely different. We see an extremely dense atmosphere that's at least 50% more dense than the atmosphere of our own planet, and that seems to be billions of years old. And so a different study from 2025 suggested that the processes in Titania's interior might be constantly resupplying the methane. And specifically here we're talking about cryovolcanism, basically an ice volcano, mostly because instead of silicate magma, Titan essentially contains a lot of molten ice, playing a very similar role. And so the high temperature reactions inside the moon may be responsible for replenishing all these materials. And this was recently supported by the detection of what's known as argon-40, an isotope of argon detected in the atmosphere that's technically a product of decay that should only be present if material is emerging from some kind of a rocky interior, not just the icy crust. And if confirmed, this would suggest that Titan is very geologically active, and its volcanoes seem to be responsible for replenishing the atmosphere, I guess kind of similar to our own planet. But in this case, the volcanoes are ice volcanoes, or technically cryovolcanoes. Then, around the same time, we also had another study in regards to the bizarre wobble. This is something that's also related to the atmosphere, and here this involves a strange dynamic in Titanian's thick, hazy air that makes the atmosphere itself wobble like a gyroscope. So here it's not the moon that's wobbling, it's the atmosphere. And so based on 13 years of Cassini data, researchers discovered that the atmospheric tilt changes seem to correlate with the seasons. And in this case, every season lasts approximately 30 years. And this behavior is a little bit puzzling because the atmosphere seems to act by itself as if it's disconnected from the surface and is not influenced by either Saturn or the sun. So basically it's wobbling, but we're not really sure why. And while trying to understand this is obviously important for understanding how these worlds are different, but also because of the upcoming Dragonfly mission that's going to be flying in this atmosphere and whose descent, landing trajectory, or even the exploration of titanium surface may actually be affected by this if we don't figure out what's happening here. But we'll talk about this mission very soon because it's actually getting closer and closer to its final launch. But when it comes to Titan, one of the most compelling reasons to try to explore this object is really because of its unique chemistry and the potentials for discoveries in terms of astrobiology, and because it obviously has so many surface liquids. But there's always been this mystery, the mystery of the missing deltas. And that's because here on Earth, all of the major rivers always end with a delta. And these normally preserve some kind of a geological history and a lot of sediment, telling us a little bit more about how the river evolved. And so given that Titan also has rivers, and specifically liquid methane rivers, scientists expected something very similar involving hydrocarbon deltas. But the new analysis from April of 2025 discovered that Titan is largely devoid of these very common formations. And at first it was not clear why. As a matter of fact, by using computer modeling, scientists discovered that all of these deltas should be visible to the Cassini's radar. Yet for some reason, only 1.3% of all of the large rivers on Titan seem to have something resembling deltas. 98.7% don't. But there is at least one potential explanation. Here the hypothesis suggests that the rapid sea level changes or very powerful coastal winds and tidal currents may be preventing sediments from building up and could be destroying all of these deltas before they can stabilize. So maybe the surface here is just way more dynamic and the liquids are constantly changing. But that's just a hypothesis and we don't really know the exact answer. And then we have this study. This is the most recent one from October of 2025. And this is perhaps the strangest recent discovery that basically nobody expected. Here this involves the actual chemistry that's potentially happening inside these lakes and rivers. And here this new study challenges the assumption we've always had in regards to chemistry of similar liquids. And if you still remember your chemistry class, there was that famous expression, like dissolves like. So for example, water and oils don't really dissolve each other because they're just a little bit too different chemically, but oil and any other non-polar molecule would be dissolvable and can easily create a solution. And so this rule of polarity in molecules and the repulsion of polar and non-polar molecules that's very common on Earth seems to be maybe a little bit different on Titan. Now on Titan we have methane and ethane, which are non-polar, and we have water, which is polar. Although in this case, researchers focused on hydrogen cyanide, which is a highly polar molecule that's abundant on Titan as well. And by the way, it's also known to be a precursor for a lot of life molecules, including a lot of amino acids. And this research involved experiments. Experiments conducted in Titan-like temperatures of minus 180 degrees Celsius that revealed something nobody expected about hydrogen cyanide. Even though hydrogen cyanide becomes a crystal and methane and ethane remain a liquid, to everyone's surprise, these substances were actually interacting, even though technically they shouldn't, with the computer models confirming that the nonpolar methane and ethane infiltrated the hydrogen cyanide crystals and formed a new stable structure referred to as a co-crystal. Basically something that we don't really see much on Earth, except for, I guess, in a lab. Which means that at extremely low temperatures, like the temperatures on Titan, because molecules don't move as much, they allow substances that usually repel each other to then combine. And that is kind of mind-blowing for a lot of astrobiological studies, and of course, chemistry. Here, this discovery, assuming it's confirmed, is definitely going to reshape our understanding of chemistry in supercold environments, and obviously chemistry in the rest of the solar system, where temperatures are kind of similar. Because this basically implies that in a lot of these very extreme conditions, we might be able to have additional chemistry involving a lot of these complex organic molecules, which once again, if confirmed, is going to be a super exciting discovery for astrobiology. It might imply that life can maybe form in some really bizarre conditions we never expected. And so this directly ties to our search for extraterrestrial life. And furthermore, at least one other study even proposed a kind of a pathway for the potential formation of protocells or initial life cells in these titanium conditions. This was published on July 2025 by Christian Mayer and Connor Nixon, and involved a hypothetical scenario of the formation of early cells from the structures known as vesicles, resembling small bubbles. And on Earth, we believe maybe this is how life started here as well. And the central explanation focuses on molecules called amphiphiles, molecules whose one end attracts liquids, another end attracts fats. This is obviously something that exists on Earth as well. And on Titan, these molecules, if they exist in abundance, can form a very thin film on top of the liquid methane lakes. It would basically resemble something like this. And so when methane rain splashes the surface, it might be able to create tiny droplets coated in thin film that then can hypothetically form vesicles. And so as these droplets fall and sink into the lake, they might become coated in a second layer of amphiphiles, forming a relatively stable double-layered vesicle, which is in essence not so different from some kind of a protocell that we know has been formed in the lab on Earth in various experiments. And naturally, this membrane bilayer would be crucial for any biological cells, at least on our own planet. And so existence of any vesicles similar to this on Titan would definitively demonstrate an increased chance for a potential life here, or at least conditions that might one day result in life, just like they did on Earth. But I guess more importantly, this hypothesis proposes a path for life, non-water-based life, perhaps using methane as a solvent as opposed to water. So here we're talking about methane-based life. A pretty exciting proposition, but obviously until we go to Titan and until we collect some of the samples, none of this is going to be confirmed. And last but not least, there was also discovery in regards to the winds on Titan, which might be super strong, or at least be able to carry a lot of stuff just because of the thickness of the atmosphere. And so here, because of the relatively low gravity on Titan, combined with the extremely dense atmosphere, the potential for wind to carry stuff is at least 80 times greater than on our own planet. So that means that if there's any wind, and especially strong wind, it's going to be able to carry anything away unless it's absolutely massive. With the modeling suggesting that ice stones up to about half a meter or approximately 2 feet in diameter could be easily rolling around Titan at all times, creating a very bizarre landscape. Essentially, imagine a landscape where a lot of boulders are always moving around just because of the wind. And this is something we need to be definitely aware of, once again because of that Dragonfly mission that's going to spend a lot of time on the surface. And so dynamic weather, strange chemistry in the lakes, active cryovolcanism, and of course these rolling boulders may all actually make this mission a lot more difficult, because the helicopter itself is obviously not going to be too heavy and it is going to be pretty small. And so this nuclear-powered helicopter scheduled to launch in 2028 may find itself in a truly alien world with a lot of really bizarre conditions. But it also is going to be one of the most important missions by NASA, possibly ever. A mission that might be able to find a lot of answers for astrobiology and the search for extraterrestrial life by actually looking right here in the solar system on one of the most exciting moons. And though it is going to be studying the surface composition and trying to characterize habitability of Titan's environment, unfortunately it's not going to be able to detect protocells or bacterial cells directly. It's mostly just going to focus on chemical analysis. But by 2035, we will probably have a lot of answers about Titan, because by then it will have spent at least 1 year on the titanium surface. So yeah, it's not really happening anytime soon, but it's only 10 years. Either way, based on all of these discoveries, this research once again presents Titan as a super exciting world, enriched in a lot of carbon-containing organic chemistry, and even chemistry that we actually didn't expect, and chemical reactions involving methane that might have had a chance to produce something incredible, such as a methane-based life that we obviously have never seen anywhere before, which makes Titan extremely important in terms of scientific significance, because compared to everything else in the solar system right now, this is maybe one of the most exciting worlds where we do have a high chance to discover something. And if not life, then maybe new chemical reactions and new chemical lessons that we just have never considered before. And so here Titan is forcing us to realize that our knowledge is definitely incomplete, and that super complex organic reactions seem to be way more common in the solar system than we ever thought. Anyway, we'll definitely come back and discuss this more in some of the future videos, because there's definitely going to be more research. Until then, check out some of the previous videos on Titan in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. Alternatively, you can also buy the wonderful Protocell t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.